Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulhilmi bin Zulkifli and a final year student of Mechanical Engineering at UiTM Shah Alam. I am here today to talk my beloved panel about final year project for Mechanical Engineering student. First, I would like to introduce my helpful supervisor, which is Dr. Fazli Adull Manan. Also, I would like to thanks to my panel, Dr. Abdul Manaf bin Abdullah and also Dr. Abdul Halim bin Abdullah. I really appreciate your keen interest in this presentation, which has taken myself to prepare for you. My FYP project title is Computational Analysis of Hybrid Biomaterial. For the details, soon I will cover from slide to slide. So for background research, what is a biomaterial? The term biomaterial was redefined as a substance that is not a medicine that is appropriate for incorporation into systems that improve or replace the function of physiological tissues or organs. Material that is not a medicine that may be utilized to cure, augment or replace any tissue, organ or function in an organism. Aloe vera has been utilized for health, aesthetic, medical and therapeutic purposes for ages. Aloe vera also grows wild over the globe in humid, semi-tropical and desert areas. Since its identification, it has been regarded as a natural healer. Properties of aloe vera such as wound healing, anti-inflammatory and antibacterial has been observed. Therefore, the hyperelasticity theory is adopted in this investigation. For problem statement, first, aloe vera has been researched sparingly in the context of a mesh or mat such as electrospun or 3D printed scaffolds. And second, hyperelastic model implementation is not clear due to the difficult approach for calculating stress and elasticity tensors. And then move to the objective. This research aims to determine computational analysis of hybrid biomaterial based on aloe vera using two important hyperelastic models, which are Ogden model and Munir-Rivlin model. Thus, the objective of this project are as follows. First, to generate a three-dimensional finite element model using ANSYS mechanical FPDL software. This objective focuses on constructing a simple three-dimensional model for usage in ANSYS software in order to acquire deformation and displacement of a hybrid material based on aloe vera with high accuracy using Ogden and Munir-Rivlin characteristics. The three-dimensional model is built using experimental data acquired from literature. Additionally, the development of a three-dimensional model allows the nonlinear hyperelastic behavior to be characterized and the model mesh into elements. Next, the second objective is to analyze the stress, strain, and stress of hybrid biomaterial, which is aloe vera, under various boundary circumstances using ANSYS software. The second objective is to simulate the reaction of hybrid biomaterial based on aloe vera skin with varying parameters and boundary conditions using the Ogden and Munir-Rivlin models. As a result, this computational analysis may be carried out without the necessity for experiments. This aim will demonstrate the nonlinear and anisotropic behavior of a hybrid biomaterial based on aloe vera. For methodology, 9 steps had been followed to achieve the expected outcome from this project, which are first, study of experiments, next, application of material properties, and then development of geometry model, process of meshing, application of boundary conditions, results data collection, comparison of hyperelastic models, experimental comparison of models, and lastly, discussion and conclusion. For material property selection, mechanical study of soft materials and biotissues, parameters for infinite element model has been determined, while for FEA modeling, model has been matched into 18,032 nodes and also 3,234 elements to get better results. Next, to create the boundary conditions, constraints have been applied in UI, US and UZ direction at one side of the model. At the end of model is applied with a direction force or load. The force applied on the end is 14 Newton. Only one case is shown in the figures. Additionally, to simulate multiple analysis at once, design parameterization is employed. Consequent results are shown in tables and graph in the next section. For data analysis, the formula shown in the slide been used to get the necessary result. Next, for results of the project. All the study has been computed in forms of results based on the requirements. Nodal displacement has huge effect on mechanical properties of materials. The mechanical properties that are being observed are strain, stress, and stretch. For Ogden and Monirevlin model, axial and angled loading has been applied for experimental investigation of biomechanical materials. The results of this table has been shown by graphs in the slide. Generally, the increase in value of stretch, the value of stress also increase under axial and angled boundary conditions. It has been shown by the two graphs as a comparison. For first boundary condition, the results are showing that under axial loading, there is less increase of stress as compared to angled loading. Under angled loading, the components of force divides into X and Y component, due to which their value varies a lot in both directions. In axial loading, less deformations occurred in Monirevlin model than Ogden model. Higher stresses occur in Ogden model under axial loading as shown in the table. In both Ogden and Monirevlin model, in first boundary condition, it has been seen that value of stress is increasing with increase in value of stretch. Ogden model is showing maximum stresses than Monirevlin model, which means using Monirevlin model, less value of stresses occurs in biomechanical materials. On top of that, for second boundary condition, the results are showing that under angled loading, there are more deformations produced in Monirevlin model than Ogden model. This is due to dividing of loading conditions into X and Y components, due to which their value varies a lot in both directions. Due to higher deformations in Monirevlin model, value of stress also increases, but in Ogden model, stress value becomes higher due to increase in value of stretch as shown in the table. In the second graph, under second boundary condition in angled loading, value of stretch almost reaches to the same values, but in this case, in Monirevlin model, value of stress remains minimum. In both cases, value of stresses always increase with the increase in stretch, but for Monirevlin model, value of stress become almost constant after specific points. This means that less value of stress occur in both boundary condition for Monirevlin model. Meanwhile, for Ogden model, value of stress keep increases to a maximum value compared to Monirevlin, which behave almost the same with the first boundary condition. As a conclusion for this project, first, research has been done with theoretical and experimental study for computation of biomechanical behavior using multiple boundary conditions. Next, aim of this research has been done in which 3D model has been analyzed using finite element analysis at zero and some angled loads. Lastly, results of both models shows different behavior in FEM approach. Limitations and advantages of the study has been shown by comparison of the results. Some recommendation might be useful for other researchers, which is they could use different boundary condition and load on FEA model for evaluating better results. On top of that, the other boundary condition like pressure could also be used to evaluate performance of the model. I think that's all from me. I hope you enjoy my presentation, and thank you very much to the panels for lending your time to hear my presentation, and have a good day. Assalamualaikum warahmatullahi ta'ala wabarakatuh.